Assalamu alaikum. The topic of my presentation is free valve engines. Free valve engines are engines that have been patented by Koenigsegg and Freevalve. These are sister companies. These are camless engines. There's no cam in them. Koenigsegg is this super nice company. It's a Swedish company. It has broken speed records for supercars, and it's pretty exclusive. It has made like, I think, less than 40 cars a year. So yeah, it's come up with this new technology, which they use in their car called Gemera, but it's not really commercially out yet. Okay, so why is there a need for camless engines? So let's start from the basics. The aim has always been for engine manufacturers that we have optimal combustion. There are reduced emissions, and we have more power and less fuel consumption, obviously. So what we've done so far is we moved from carburetors to EFI. Carburetors had this almost fixed ratio of air and fuel. So there's a lot of wastage there. So we moved to electronic fuel injection, which sprays fuel and it's electronically controlled, and air is controlled through throttle. So emissions are also controlled, and we've got better efficiency. Then we moved to dual overhead cams, so that we can control the opening of valves. And Honda came up with the VTEC technology, which they use in VTI. In this, the ECU reads the amount of throttle, and there are two cam profiles in them, which it can switch between according to the need. But still, we've not got infinite control over the valve. It's still cyclic. So why not like open or close the valves anytime we want? This can only be done electronically if we want it to be infinite, since cams are a mechanical device and the profile has to be followed, right? So camless engines are of mainly three types. We've got the electromechanical ones, electrohydraulic, and free valve. Electromechanical just have this electromagnet and this current flowing, which kind of controls the lift and the opening and closing. And in the hydraulic system, obviously, we have an oil hydraulic system. So the hydraulic pressure controls the valves. But since that's not part of my presentation is a free valve, so we're just going to get into that, right? So free valve uses both pneumatic as well as hydraulic systems. It has this, I'm just going to, okay, I can't. So this blue thing over here, this is called the rail, and it has these electronic connectors. It has all these passages for air and oil, right? This is the rail, and these are the actuators. They're going to have the spring in it. There's going to be a spring with it, and they're going to have these are basically the valves that we're going to be opening and closing. So this is a retraction spring, and this is the piston. And these are position sensors to check the how much the valve has opened and closed. Right, let's just get to the actual presentation. So we've got solenoids for the opening and closing of the valves. The rest I've explained with the video, and I'm going to explain this with these diagrams. So this is a basic construction of the actuator. This is the passage for the air. So this is the pneumatic bit. High pressure air comes in and goes out through here. This is the oil chamber. So high pressure oil would come in through here and go out through here. This is a small bleed valve, really small hole over here. I'll explain its working in a bit. Okay, so in order to open the valve, the spring is going to be here. The retracting spring we saw in the video is going to be right here. So in order to open the valve, in order to open the valve, you're going to open this and these check valves here. So air is going to come in. It's going to push this piston downwards, and high pressure oil is also going to be there to ensure that the piston goes downwards, right? The spring will make sure, one of the elements of the spring is to make sure that this movement isn't too sudden or so it doesn't damage the system. So it's going to cushion the movement of the piston downwards. This bleed valve makes sure that there is no vacuum over here, so that it doesn't work against the piston. Right. Now, okay, sorry, I forgot to mention one thing. So once it's been pushed to the lift that we want, there are going to be position sensors here, which will tell us the lift that has been achieved. And once that has been achieved, we don't really need the high pressure air anymore. We've got the hydraulic system, which will kind of lock the system. So even if there's a little bit leakage of air, if something goes wrong, the hydraulic system will make sure that this piston is locked downwards, and there are going to be seals around here to make sure there's no oil leakage, right? Now to open the valve, sorry, to close the valve, we're going to open these and close these outlets, right? So once this is opened, air is going to go out through here. The piston is going to be pushed upwards. This bleed valve again will come into play to make sure that since it's a really small hole, so this oil is going to flow really slowly. So it will cushion or like dampen the movement of the piston upwards, right? So that's it. Now let's come to the advantages. So we've got independent control over each valve. I'll explain this in a bit. There's a major reduction in size and weight, obviously. We can easily run the Atkinson cycle since we can control the lift and the timing of the valves. And we can switch between different cylinders. It's got independent control. So we can switch between different cylinders. The ECU will just like open the corresponding valves. And it's been optimized, which we'll discuss as well. So variable valve timing, we can control the lift, which means how much we want to open or close the valve. So you can see variable lifts over here. We can control the duration of the lift. So this is the peak, the amount, so the duration. So this is how long it has been opened or closed for, and the timing. So when we want to open and close it, that has also been controlled. With the camshaft, you have a mechanical profile which has to be followed. So it opens. With the cam, what happens is that valve opens, reaches peak, goes down, opens, reaches peak, goes down. So it just stays at the peak for a moment. But with this, you can stay for however long we need it to. Right. So we don't need a timing belt. We don't need a timing chain. So we've got a narrower engine. We don't need the cams overhead. So we've got it's shorter as well. There's 15% reduction in weight, 15 to 20 kgs lighter. So this is the supercar that Koenigsegg has recently come up with. It's called Gemera. It's the world's first four-door supercar. Usually, we don't have four-door supercars. Why? Because for supercars, the ideal position for the engine is in the mid-region, right? So if you have an engine there, you don't really have space for the passenger seats or the doors. So, but this car uses free valve technology, and it uses it just uses 3 cylinders with a 2-liter capacity, which has not been seen before. And it can produce up to, just the engine alone has around 500 Newton meter torque and up to 500 horsepower. So which will obviously increase with the amount with the turbos, etc. So yes, and so there's going to be lesser fuel consumption, and emissions have been reduced a lot because it has better cold start. So why isn't this being used all over? Why isn't it commercially available? Well, mostly because of the cost. You're going to need an additional air compressor for the pneumatic system, and we're going to need high precision sensors for the lift and like check everything. So, and cams are just, they're not really expensive. So yeah, this is going to increase the cost. Testing, well, for passenger cars, there's still going to be a little bit of testing, but since Gemera is out, so that's not really the issue. The cost is the issue. So if you've got any problems, please contact me. I'm running out of time. Allah Hafiz.